Now that we've learned completing the square, we're going to use this process to help us solve quadratic equations. Now, in past lessons, we've learned how to solve quadratic equations through factoring and square roots. However, we're going to see that at times we're going to get a quadratic equation that can't be factored, nor can we use square roots. So this is where the completing the square process is going to allow us to solve any quadratic, no matter what the form of it is. So first thing we have to understand and we have to take care of is that the leading coefficient has to be equal to 1. So if we have ax squared plus bx plus c, and let's just say that equals to 0, this leading coefficient needs to be equal to 1 for us to complete the square. And if it's not, we're going to need to divide everything by that number. Now, this may create a fraction along the way that we may have to deal with, but we'll start off with a more basic example that has a leading coefficient of 1, and let's see how we would use completing the square process. The first thing we're going to do is recognize that we cannot factor x squared plus 10x minus 3, nor can we use square roots because it has a b term. So since this is not factorable, what we want to do is we actually want to move this 3 out of the way, and we do that by adding it to both sides. And this leaves us x squared plus 10x on the left side by itself. And of course, that should look similar to the setup that we were just using to complete the square. Now, in this process, we are going to complete the square, and we're going to have 5 squared, or we're going to have 25. Now, we would add that to x squared plus 10x to make a perfect square trinomial. Now, the important thing here you have to remember to do is that in the golden rule of algebra, it says to keep the equation balanced, whatever you do to one side, you must do it to the other side. So it's very important that you add that 25 to the other side as well. And so then we factor that perfect square trinomial to a binomial squared. And you can see we have x plus 5 squared equals to 28. Now, we've seen problems like this before, so we can take the square root of both sides and get rid of that square, and then work down until we have it in the most simplified form. So x equals negative 5 plus or minus 2 times square root of 7 would be our final two solutions. So completing the square can be very useful, and it can be used for any quadratic equation as long as we can get that a, or that leading coefficient, equal to 1. So let's move on down to sample problem number 2. We have two problems here actually that you can do. Sample problem number 1 and then sample problem number 2. Now, they're going to give you various, a couple different looks at two different types of completing the square problems. So go ahead and try to work problem number 2 and problem number 3 real quick. Okay, let's take a look at this. At first glance, you might see the 8 and say, oh, negative 2, or 2 and 4 could multiply to get 8 and then add up to get 6. The problem is the signs give us an issue. We don't have two values that would be able to give us a negative 8 and a positive 6. And so we're going to have to use completing the square here. So what we're going to do is we're going to simply add 8 to both sides and clear some space. Now, what I kind of like to do is actually give myself something to fill in, and then of course if I add something to the left side, I have to add it to the right side. And so we've seen x squared plus 6x before. We did that on this previous problem where we had the 3's and added up to 9. So if you were using the little formula we gave you, that would be 6 over 2 squared, which is 3 squared, which equals to 9. So we're going to add 9 to both sides, which is going to give us x plus 3 squared, or you could do x plus 3 times x plus 3 first if you feel more comfortable. And now it's equal to 17. Now we have a binomial term squared. We can actually take the square root of both sides, and of course that cancels out the square. So we have x plus 3 equals to plus or minus the square root of 17. And then we want to get x by itself. Remember, we want to write this negative 3 in front of the plus or minus. And since 17 can't be simplified, square root of 17 can't be simplified, we have our final two solutions. So That's a basic completing the square problem. Now if we look at sample problem number 3, we run into a different problem. We have a leading coefficient that's not equal to 1. So like I told you before, you may need to divide this value out. So we're going to divide out the 5. And if we do that, we have to divide everything out across the board. Now, get a little lucky here. When we do this, we're left with a trinomial still equaling to 0. And now I can move the 6 out of the way to give myself room to complete the square. And so if I want to complete the square, my c value is -2 over 2 squared, which is -1 squared, which is equal to 1. So I'm going to simply add 1 to both sides. And this will be x minus 1 squared equals to -5. And if you want to look at this value right here, after the b has been simplified with 2, that -1 is what's going to pop up in that binomial squared. Take the square root of both sides and get x minus 1 equals plus or minus the square root of -5. And if you remember, we cannot have a negative square root in there, or negative value under the radical. So this is going to break up into square root of -1 and square root of 5. So that's where we get the imaginary number from. Okay, and there are two good examples of completing the square to help us solve quadratic equations.